Okay, let's get started. So I'm Debbie Liu. I'm the Executive Director of ESIG, the Energy Systems Integration Group, and I wanted to welcome everyone to an ESIG webinar. For those of you who are not familiar with ESIG, we are a membership-based nonprofit organization. We provide members with objective information, resources, and networking opportunities in support of clean energy and energy systems integration decisions. And we do this through workshops, tutorials, webinars like today, blogs, working group, and task force activities. And we also produce technical resource materials. For those of you who are members, thank you for your support. It makes these webinars and our other work possible. For those of you who don't know, we're going to be holding our spring technical workshop in Tucson during March 16th to the 19th. And there we'll be talking about increasing hosting capacity, integrated planning with distributed energy resources, affordability, proactive planning. Our workshops and our webinars are open to everyone, so please feel free to register anytime on the ESIG website at www.esig.energy. You can also find us on LinkedIn, YouTube, Facebook, and X. So a few logistical matters before we get started. First of all, participant lines will be muted for the duration of the webinar to avoid distractions. For questions and answers, please ask your questions through slido.com. You will not be able to ask questions through WebEx. So go to slido.com, enter ESIG13 as the event code. Instructions are at the bottom of the screen. You'll see a thumbs up button next to questions that will allow you to cast a vote to help prioritize the questions that are submitted. And we will save time for questions and answers at the end. And we will wrap it up in 90 minutes. And an email with a link to the recording will be provided once the video of the recording has been posted. We'll also plan to provide short responses to unanswered questions after the webinar. So please don't be afraid to ask your questions through slido.com. So today we are going to hear from Alliander from the Netherlands about their work managing distribution system constraints using customer flexibility. Now in the US, we've been talking about distribution system operators, DSOs, for a long time. In Europe, they've actually implemented these solutions. And there's a lot that the rest of the world can learn from these experiences. Now, you may know we typically don't make full use of the distribution grid. It's typically planned and sized for peak conditions, and there's many hours of the year when there's excess capacity and that system is underutilized. Additionally, sometimes customers want to connect DERs faster than the grid can be upgraded. Having those customers provide flexibility to connect more quickly in advance of the grid being upgraded can help. And last year we had Avangrid discuss flexible solar interconnections as a way for a single customer to connect more quickly. Alliander takes a different approach. In order to increase the utilization of the existing distribution infrastructure as much as possible, they create customer programs, they create markets, they compensate customers when those customers provide flexibility. So I'm really excited that we get to learn more about the details of their approach. And we have 4 members of the Alliander team here to discuss this. We have Nigge-Uricher, a senior business developer. We have Akhtar Hussain Javed, a policy advisor in operations. We have Mitchel, Haeve, a product manager in system operations. And we have Manuel, Dakessian, an energy expert system operator. Just a short reminder once again to use slido.com with the event code of ESIG13 to ask any questions. And without any further ado, let's go ahead and get started. And I'll turn it over to you, Mark.
Perfect. Thank you very much, Debbie, for the introduction and the opportunity to speak here. So today, we want to start basically with, giving you a short introduction of who Alliander actually is. It's a Dutch DSO, as Debbie just mentioned. And then we'll dive into a couple of further points. So Akhtar, if you may already switch to the agenda, The topic of today, of course, as you saw, is managing flexibility. So first of all, a short introduction where I will myself explain you the situation that the Netherlands finds itself in. I'll then hand over to Akhtar, who shows you the strategies that we are implementing and the policies and flexibility frameworks that we're working with in order to counter those issues. I'll then continue with Mitchel, who shows you our given world. With that, basically, we mean what do we do ourselves within the framework that we are having for us to make ourselves improve. To then finish with Manuel, who shows you already a bit on what we're doing also to work towards the nearby future and improve even further the situation. I'll then conclude myself again with some key takeaways before we enter into the question and answer session. So what's Alliander? Alliander is a network company, and we basically serve within the Netherlands around about 3.5 to 4 million customers. Just for a quick overview, the Netherlands overall has about 20 million inhabitants. Alliander is within the DSOs the largest. There are 3 major DSOs, of which Alliander, as you can see here on the map, we serve the green and orange area, with the green area being the electricity area and the electricity and gas area, and the orange part being the electricity only area. The others are then served by our peers here within the Netherlands. We have a total length of our grid, basically of around 93,000 kilometers. Most of it, and that means more or less 99%, is underground. And we have in total basically completing connections in a total of 6 million connections. So that's not only our customers, like large and small customers, but also other kinds of connections like street poles or charging stations, public charging stations, and so forth. So this just to give you a short overview of what we are and who we are. And with that, I'd like to directly jump into the issues that we're facing. So on the coming slide, what you see here, and maybe you can switch a bit back because it's animated, Akhtar, so that we can actually, oh, the animation is gone. Okay, no worries. Well, then if you switch back, so what we see here is a map of the Netherlands, and this is a capacity map. And what you see is basically on the left-hand side is the consumption. So this is where customers withdraw energy from the grid. And you basically see for the overall of the Netherlands, this is quite red. Red is, of course, a bad sign, which basically means that there's more capacity requested than we could serve. On the right-hand side, that's the same, but for generation. So customers putting energy into our grid or into the Dutch grid. And what I actually wanted to highlight here is that over the past 2 years, so I started capturing these maps from spring 2024 to now winter 26, and had also a picture of summer 25. And you could only see that the situation worsens. So basically, by now, almost the whole of the Netherlands has some capacity issues, with some space still available in the orange areas, but largely it's red. So when we continue, what does this actually mean? It basically means also from and this is basically on the backside, so the energy transition. What we have basically already customers in total that feed in local or decentral energy with more than 1 million of the 3 million that we have in our customer base. There's also a total of oh no, sorry, that's for the overall of the Netherlands. Then we have a total of 20,000 connected charging stations. And there's also a big part of solar generation and wind generation. As you can see or remember from the map, we're a coastal country, and that basically sees on the graphs on the bottom right that over the past years, the solar generation and the wind generation has largely increased from when you see just underneath the bar chart and where the yellow bump is still quite small to increasingly yellow on the right hand side. So that's basically the generation. What that basically all boils down to is what you see centrally on this chart. It basically means that until 2030, we expect to have 20,000 or roughly 20,000 customers requesting a connection, and this can be generation or consumption. And this is for the overall of the Netherlands. And 20,000 customers, that's quite an economic impact, because it basically means that companies need to wait for an increased connection or for a connection at all if they build a new site. So they cannot grow their business in that time. And that even goes sometimes down to household levels where new neighborhoods were built and the buildings are ready, but the people cannot move in yet due to the missing connection. So it's basically across the board, all the connections. So what does it mean just from an Alliander perspective? Because the 20,000 is the total. So on the next slide, you see that our customer waiting list that we are basically following up by ourselves. And here you see that we have in total roughly 9,500 customers, generation and consumption, waiting for a connection. And the positive side of this is that we were able over the last half year or so to stabilize this number for ourselves by offering the flexible connections that we will dive into during this webinar in more detail later on. So with that, I would want to basically ask you already a first question where you maybe could put your answers into the Slido already so that we can make this also a bit more interactive throughout the course. And that's basically asking, what is your current challenge when it comes to capacity, if you have any, of course. And please share that with us, and then we can maybe already dive into your answers to your questions that you're facing throughout the session. And with that, I'd like to conclude and hand over to Akhtar, who then will walk you through our strategy from a company perspective as well as from a policy national level.
And Mark, let me just explain to the participants. So you need to go to slido.com. You need to enter an ESIG 13, and then there are two tabs at the top. One says Q&A, and the other one says polls. You need to go to the polls tab and then type in your answer to the question. Thanks.
Yeah, thank you, Debbie, for clarifying that. So Akhtar, over to you.
Yeah, thank you, Mark. And good morning to the US audience, and good evening to the audience here in the Netherlands. So I will talk about what is Alliander's strategy and some of the policies and some of the flexibility framework we use. First of all, Alliander's strategy. So our goal for 2030 as Alliander is that we want to supply all the customers a connection. And then we want to make our energy system in Netherlands sustainable, reliable, and cost efficient. And to do that, we have 7 pillars of our strategy. And the first one is excellent grid management, which means that we optimize the maintenance and improve our customer services. Then second one is that we reduce the demand for transport capacity. So this is could be done via the efficiency measures or via the different kind of contracts and different kind of tools we have. And then third one is better use of the net or better use of the grid. This is the main pillar of related to congestion management, where we will be talking more in details later, especially Mitchel will talk about different kind of capacity restriction contracts and redispatch contracts. So these fall under the better use of the net. Then other pillars include create more work, data sharing and development of new market services, and then developing infrastructure for heat and sustainable gases, for example, for hydrogen. So we are working to have hydrogen integrated in our system. And then we also want to have a future-proof foundation for our future energy systems. Then, yeah, so as we see the strategy, we as a company have also evolved from being a distribution network operator to a distribution system operator. So what's the difference between them? As a distribution network operator, we are more focused on asset management and grid management. But with the challenges of energy transition and with the challenges that there is a less capacity in the grid, we also need to include other business area, and one of them is capacity management. So we also evolving ourselves to operate for capacity management, and this is done via the so for example, for capacity management, we in Netherlands have a local service market which is called GoPax, and we interact with customers and with big flexibility service providers via this platform, via the GoPax, and that is shifting our focus from being a distribution network operator to a distribution system operator. Yeah, and now I will give you a brief timeline of congestion management regulations, because as you all know that electricity is a very regulated sector, and regulations play a big role, and we are limited by what we can do by the regulations. So the regulator in Netherlands is ACM, Authority for Consumer and Market. And in August 2021, ACM proposed a congestion proposal, which meant that if there is a customer who wants a connection with our grid, we must do congestion management before we can refuse such customer. And then after that, in May 2022, there was new grid codes for congestion management, which gave us a toolkit of congestion management, and it proposed capacity limitation contract and redispatch contract. And then one of the landmark regulation, or you can say a plan which came, was National Action Program. This National Action Program was developed with all network operators, with the DSOs, with TSOs, with the government, all on one table, to how we can solve the congestion problem. And I will discuss about this one in next slide in a bit more detail. Then there were some other regulations along the way. For example, what is the definition of controllable capacity in the grid, and how we can have standard contracts for renewables, especially for wind and solar. And then in early 2026, from the beginning of this year, we have a new prioritization framework. Like if there is a waiting list, which kind of customers we need to connect, and what is their priority in the network.
Akhtar?
Yes.
Akhtar, your volume is a little bit low. I wonder if you could just, yeah, that would be great. Thanks.
You're welcome. Okay. So I need to speed up. I think I'm lagging behind. So the next action plan actually had three main core areas. One was that because there is a congestion, we need to build our grid very faster. And in this plan, there was integrated approach recommended, where it was asked that all the parties, for example, provinces, national governments, and municipalities, they will work together to allow for fast permitting of the grid expansion project. And then second one is better use of existing grid. So this one is where also related to congestion management, where we develop flexible and time-bound contracts, and we do the congestion management measurements to utilize our grid as better as possible, because the grid expansion take longer time, but in the meantime, we should better utilize the existing grid. And then the third one was increase the flexible capacities, how we can stimulate customers, how we can encourage consumers and industries to have this flexible energy in the systems. That was the third main point of this National Action Program. And then a little bit on the prioritization framework. Since we have a lot of queues, as Mark mentioned, with customer waiting to be connected with the grid. So we have a new prioritization framework where if you fall in these categories of congestion mitigators, as you are a safety entity or you have basic needs, then you will be given the connection first. And after that, there will be the other parties demanding connection. And for congestion mitigators, these are the parties which can help reduce the grid congestion, and they can also be controllable. And with them in the system, we can take more risk, and we can have more controllable capacity. Then we have the safety organizations. So these are the organizations like fire brigade, emergency medical care, ambulance, police, which will be given second priority. And then third one is like education, drinking water, housing, and electricity and heat gas companies, which need their connection. Previously in the waiting list, we have different kind of waiting lists for big, large customers and small customer. But this distinction is also being removed from the beginning of this year, or I think from the mid of this year, 2026. So where we will have now one queue for all customers. Okay. Now this is again further regulation, but the point I want to make here is that this is a typical load profile in orange color. But if we see that we reach a congestion at this point, but our grid is remain unused for a lot of periods, and what we are essentially trying to do in future is that we are trying to utilize this unused capacity from the grid. Yeah, so a little bit about what kind of instruments we use to increase the flexibility or do the congestion management in our grid. So the first instrument we use is called contractual differentiation, which means that we sign contract with our customers with alternative transport right mechanism, which can give us implicit flexibility. For example, if we say, our grid is fully occupied in the peak hours, but we can give you a grid capacity in the off-peak hours. So are you willing to accept that? And if the customer accepts that, then we kind of get the flexibility from that kind. And we have these kind of time-bound contracts, and we have flexible connection agreement for this one. The other one is technical solution, where we, as a DSO, can take more risk. For example, we have a policies like sweating the assets, which means that we can go above the rated capacity of the components, given that the time it goes above is very small, and we come back to the capacity as soon as possible. Then we have other mechanisms like market-based optimization. The main one is congestion management, which is also like the main point which Mitchel will be discussing in short. So, and then we have also some temporary tolerated agreements or solution, like we have dynamic feed-in. So with the voltage set points, if there is a higher voltage, we reduce the power going into the system. And to do all of this, we have developed a software which is called GaaS, which will be explained in short. And with this GaaS, we actually do the grid management or capacity management of our network. And there are different stages of development of this software. So for example, if we extend the grid, we get the capacity, so that's not a problem. So focus of this presentation today is use of congestion management, how we can use capacity limitation contracts, redispatch contracts in day ahead and on and intraday markets to get the to keep our grid within the limits. And if we cannot do that, then we have to use some actions like real-time emergency curtailment of the customers. So that's so that's how we do it now. But in future implementation of the GaaS, we also want to include the factors like how we can reduce the frequency control impact. For example, if there is a customer in our grid, in the DSO grid, but it is providing frequency support to the TSO grid, and if it provides that support and it can, impact the congestion in our grid, how we can limit the impact of that participation of a DSO customer in the bigger market. And then we also want to use tariffs and alternative transport rights to give customer access to the grid in periods where there is a lot of capacity available, there is less load, so that, for example, if I know tomorrow that there will be a lot of space in the grid, maybe I can ask customers to use more capacity via the non-firm contracts. So that's how we want to build our GaaS in future. So that was all from my side. Now I will give the board to Mitchel.
Yes, thank you, Akhtar, for handing it over. And I think that's very interesting, right? So we have a lot of problems and a lot of law and policy that we need to take into account. And then we manage capacity, and I will tell you today how we actually do it. The process overview is visible in the slide over here. And you can see we make use of a central user interface called Gridmeister. But more importantly, I think for this presentation is we do several steps throughout this process actually to come to a conclusion on where to do capacity management and how. We create forecasts, we determine the topology, we find the limits of certain assets, we'll check for overloads, determine the solution, update the overload information, and verify customer behavior. And I will guide you through this process in this presentation from left to right to actually show you what is happening in our system. So what do we actually do in GaaS then, in our grid as a service system? We start by creating forecasts, and those look a bit like this. So what you actually see on the screen is a forecast using different percentiles, as we call it. Those are also given by the light blue color. So you see good 5 to 95%, a good 30 to 70%. And those give an indication of how probable it is that the load is going to be a certain megawatt. So over here, I have chosen deliberately an example which shows a very large range, because we in the Netherlands often have rainy and sunny days and they follow up quickly. So we're as certain sometimes as the weather actually is. So let's zoom in a bit on actually the bottom part of this graph where the overload was indeed, seeming to happen. And here you can actually see that for some percentile, for some certainty, we expect an overload, and for some certainty, we do not. Well, it depends, of course, as a system operator, if you want to request a lot of power flexibility, you could choose the highest uncertainty, or you could choose the lowest, meaning you would spend less, but also miss more overloads in your system. In this case, we could have sent a mitigation or actually a request to a customer, but in the end, looking at the measurement data, it was not really necessary. So in our previous slide, we saw the limit to be around 20 megawatts. Over here, we see the measurement data where minus 9 megawatts, which stands for generation on the grid, is actually done. So in this case, no request should have been sent to the customer. what I just want to explain is you're never sure it remains a forecast, of course. We make forecasts on measurement data, and sometimes this measurement data is not available, as you can see in the next slide. Awesome. Yeah, so we have a lot of measurement points on the high voltage grid, but not all measurements are taken on the medium voltage grid. And over here, you can see such a medium voltage route going from left to right. So there are different kind of assets actually on this medium voltage route: solar, wind, housing, residential areas, but also large customers like factories. And I'll not dive into depth. Manuel will explain a lot more about this. But let's assume for now we do our magic and we can estimate or forecast actually what the customers do without any measurement present. So now we have a measurement or forecast for each and every customer, also on the medium voltage route. Well, as you might know, the medium voltage route medium voltage routes can be quite complex. So I've shown an example on the slide over here. You can see that there are two main installations given by the text, but this is also where all the routes will actually leave from. And all routes are given by a different color. So you can actually see a yellow route, a light blue route, an orange route. And all these routes can actually be switched into one another. So yellow can become orange, light blue can become yellow as long as they're connected. So it's very important for us to know which route actually belongs to which asset. Because, well, if an asset, for example, a solar park, is connected on the yellow line, on the yellow route, you actually want to show that the load and the power flows are also executed on those yellow routes. So first of all, we need to make those forecasts. Second of all, we need to know how our grid looks like. We need to determine the topology. After that, we have a topology. We also need to know the limits of our system. So we do this using several systems and the OT domain, but it's very important to know the limits we're actually guarding and well, watching out for in order to say when an overload is indeed forecasted. And now piecing all that information together, we will go to the next slide, and indeed the next graph. It will show a bit like, or look a bit like this. So we have those limits available over here. So there's like 20 or minus 20 megawatt on a certain high voltage asset. We have the measurement data, which is taken in the past, of course. I do not have measurement data for the future, which is displayed as a black line over here. And we have a certain forecast. The forecast goes into the future, like I've showed you on the first slide, and that future expands for us approximately 1 week, but in 48 hours in advance, 48 hours day ahead, we can actually make very accurate forecasts. So just to summarize, I now know the limit, I now know the topology, I know the forecast of all assets. Now I have to determine, is there actually an overload present? And that looks a bit like this. So let's take the same example, the same medium voltage route actually, and let's plot in some numbers. So of course my wind farm and my solar farm actually generate power. They feed into the grid. So I've given them a plus sign, and the factory and residential area take something off the grid. So I've given that a minus sign. First of all, we need to, like I said, we need to know the limit of the cable, so they're given here. And then we can use power flows to actually see the load on the cable. So let's start from left at the solar park to the right. So the solar park generates 75, then the factory actually consumes all of the solar park energy, but also consumes more. So then it becomes minus 75. The residential area again subtracts 150, and then we have a problem, as is shown here by the orange line, the orange cable basically. The limit of this cable is 200, and the load is minus 225. Well, knowing this, or at least forecasting this, we need to solve this, right? So let's find a solution then. And we have solutions in several domains. They're all visible here. And again, I will go from left to right. So the first domain is the day ahead domain. This is actually like 36 hours before the congestion is forecasted to happen. And usually we have contracted power with certain parties. So let's say, for example, with this factory, I have signed a contract saying, hey, you can always turn off your oven, your gas turbine, whatever, and I can ask you to do so. Because I ask you to do something that is out of your regulatory business process, I will give you a certain amount of money, a certain compensation. At a certain moment in time, at least in the Netherlands, we want to keep the grid in exact balance. So there's as much usage as there is generation, and that is done after the day-ahead domain. And that's why when we enter the intraday domain, and this is more of a free market format. So the grid, again, is in balance, and we ask a certain customer to maybe help us out. So I would ask if somebody could please lower their consumption by 1 megawatt. In order to keep that grid in balance, somebody in the other part of the Netherlands, somewhere, also needs to up or lower that 1 megawatt. Otherwise, the grid is not in balance anymore. And these bits all come up at the same time, and an algorithm actually determines which is the cheapest solution to pick. So that, again, is a more market-based method. And the final method, indeed, like Akhtar already showed you, is a real-time method. This is something we do not want to use. We use this in case of emergencies because it has the most customer impact, right? So if I would switch off the factory now without any notification, that would well not be great, I think, for the factory itself. Again, and like I just explained, it also causes imbalance on the grid. If we always steer real time, then the grid will not be in balance, and our TSO tenant actually has to balance again. So double the cost, less customer satisfaction. So what we try to do within Alliander is try to communicate as soon as possible, so all the way left on the timeline, in order to keep the customers most satisfied. Yeah. Next slide now. That will be perfect. Yeah, thank you. And indeed, that would look a bit like this. So let's say I used one of these products, for example, redispatch, for example, capacity limiting contracts, and I would ask this factory to go down by 50 units, 50 amps, for example, then I would have solved my problem. In our system, we always check if we actually solve our problem. So we find a solution and then actually check if that solution is also going to work. And over here you can see the load on the cable stays below the limit, which is perfect, which is that we actually solved the solution or found the solution. And not only do we verify our solution, we're dealing, of course, with customers here. So what is actually shown here are two graphs. Let's start on the bottom right. Here we have actually sent a signal to a customer, which is given in orange, that we wanted the customer to stay below. In our user interface, we see that these blue dots are the measurement points where the customer actually listened to our request. But this customer was a bit naughty, so to say. So we went over this limit, which is shown in the red color over here. And this red actually shows or, signals our departments to call this customer, sanction the customer, all kinds of, methods to actually help the customer achieve the flexibility next time and make it more reliable. I also added a nice example on the top left here. So, oh, sorry, could you, yeah, thanks. On the top left here, so this is actual measurement data, and this is basically how a request looks like if we would request something. So over here, you can see a lot of generation, -4 megawatt. And at a certain moment in time, we've asked this customer, hey, could you please limit your output to approximately -1 megawatt for between 12 and 4 approximately. And after that, the customer could again generate whatever he wants. Please do remember these time frames, so between 12 and 4 on the, in this example, 30th of March. So if we go to evaluate, indeed, if this was actually necessary. So we evaluated, hey, the customer listened correctly, right? We asked him to do 1 megawatt. That's perfect. But did our system also behave the way we expected it to behave? Well, piecing it all together, we had a forecast at the beginning of my talk, which looked a bit like the first graph on the left. And you could see between 12 and 4, we actually had this overload planned, right? Or we forecasted the overload. So we had to mitigate something. We asked the customer to actually do something. And on the right, you can see that the customer behavior helped us relieve that congestion. So imagine adding 3 megawatts on top of the black line, then you would have for certain surpassed the red congestion limit. And what you can also see over here is still a very small overload remaining on the left part of the graph, like at 11 o'clock approximately. Our system will learn from this. Our system will take this into account for the next request. And our operators can also learn from this. So like I said, some forecasts are more reliable. Some percentiles are more reliable than others. So for example, if this is a place in the grid which we cannot forecast very reliably, we maybe need to pick a higher percentile. A higher percentile means spending more, but also taking less risk. And this is something our operators and our system do in coherence with each other to actually find a perfect balance between cost and effective requests in order to keep the system within the grid or keep the grid within system limits. That's what I was trying to say. Well, I already mentioned something about power flows and state estimations and about planning ahead. So I would like to give the floor to Manuel, who will actually tell you a lot more and a bit more in depth on how this process actually works.
Yes, thank you, Mitchell, for your great presentation. I will take it off from here, talking about tactical capacity management. Generally, this was a process that we decided was necessary because, as Mitchell explained, we now have or can control the grid 2 days in advance. And then there's another department within Alliander which does the forecasting or the grid planning for the long term, so taking into account other measures. And then there was a gap between what we could see right now and the forecast available long term in the future. So in order to cover that gap, we realized that we need more insights into the loading of our grid from here to 3 years in advance so that we can try to do the measures that we know. So the first step was indeed to create a process to get more insights, so better forecasting. And then the second is actually making risk assessment to see how worrying it is and how urgent the situation is and what actions to take. And then the third step is actually choosing the measures from the list of options that are known within DSOs that they can do to decrease congestion. And then fourth, just implement the measures. If we go to the next slide, we will see the risk assessment that we take into account. The risk assessment, I didn't want to actually show the template that we use, but wanted to say that the template looks like this, where the main factors influencing what the risk state in each station is the number of clients connected to the station, for example, the financial impact of having an overload in a station or an outage, and how many hours, the probability of its occurrence, what safety risks it poses, and then the expected overload, both in terms of magnitude and duration per day, to see the effect it has on the assets. So all of these come together to make an expert opinion on how dangerous this station is for the upcoming years and what actions we need to take, and then doing research into the available measures that we have The main measures that we rely on is to see if first we can increase the asset utilization. So if we can increase the loading continuously over the nominal capacity of some assets, and if that is still safe with the overload that we are seeing. For example, the second is actually adjusting some grid configuration. So basically, the operators who look at the grid continuously in real time can actually change some part of a grid to another, and then which basically moves load from one station to another, reducing sometimes the bottlenecks available in stations. The third one is the flexibility options that we have that Mitchel went in deep. To see whether there are large enough clients or the clients that are available can actually contribute to decreasing the congestion that we have in the specific times, and then looking into the upgrades available into the grid and seeing if we need to reprioritize these grid adjustments to help us with the congestion issue that we're facing, of course, based on how high the risk is and comparing it to the priorities available in other locations, and then basically just implementing these technical solutions. And then after this, we can see a long process, which after realizing all these steps and the solutions that we could do, the solutions that are involved, you can see them on the right side of the slide. And then on the left side, you can see the departments involved. Generally, I don't want to go in depth into each department name, but we realize that this job is not something that is only for system operations to do, because there are already processes in place throughout the entire company which already look into upgrades into grid and already know what solutions to do in terms of technical solutions. So we just wanted to have a better insight on this, so creating a higher reliability forecast that we can rely on from here to 3 years, and then looking or asking for help from other departments to find or contact the clients which have flex solutions, and then other departments which adjust the configuration. And all of this comes together in this new process, which is just trying to cover a gap between the current status of looking into the grid, not knowing what tomorrow holds, and then a future that you only have long-term forecasts available for stations. There's a lot of ground in the middle that needed to be covered up, and that's why this process does. I would also like to talk about a specific example that we did in the next slide. This was a station called Pioniersweg, located in the middle north, I think, of the Netherlands. So this station had the capacity, the max capacity of all its assets, which was around 17.7 megawatts. We had noticed that there were around 3,400 clients connected to the station. So any outage there would cause 3,400 clients to be continuously out of the grid. And then we had seen that the loading was getting higher every year because more people were switching to electrical appliances in their house, and all of the initiatives available currently, which meant using electricity more on a household level. And then we analyzed the risk of the station. We realized that it's medium. So medium generally means that we can't let it be for the other season, before the other season approaches, and not do any solutions or not intervene in that station. So we started all of the process of finding solutions. Unfortunately, flex solutions were not an option in the station, because the clients that were contributing to the load were just households, so tiny clients, and we didn't have currently a solution which can collect all of these small households and contribute largely to the grid. So we needed to find large clients, and unfortunately that wasn't possible here. But after investigations, so each station, this specific station, has 3 cables going from a main station to the Pioniersweg that we see in front of us. And then we realized that one of those cables had a 1.6 kilometers per cable, which was the only part of the cable leading to a bottleneck in that entire grid section. So generally, we saw that with a short upgrade, or a fast lane, which we call it, or a fast track, we can change 1.6 kilometers of PILC cable, and that would raise the capacity of that station, for example, for another 2 megawatts, which would allow us to be safe for the upcoming season. And then from all the solutions available, that was the one we decided to go with. And then the upgrade was successful, and then we didn't have an outage, at least by the end of the season. And that was a quick win by combining technical solutions with flexible solutions. to get the best out of your grid and best utilization, I would say. Now, another initiative which contributes to us knowing much more in depth about the entire grid. So I don't know how all of the grids around the world look like. However, the Leander grid is quite, we do have a lot of measurements in the grid, but mostly on HV level, in a sense, in the main substations that we have. That means we are generally, we are not blind, but almost blind in most of the medium voltage grid. And to be able to get insights into the different sections of this medium voltage grid, you need to have processes for that, or forecasts. But forecasts are not accurate in locations where you have never measured. You don't have a single measurement, so you can't forecast that. So basically, what we decided to go with is state estimation and, of course, power flow later on, for being able to view our grid in all its sections in a deeper way. So basically, if we go to the next slide. So basically, we are able to currently view, on the left, you can see all the branches, for example, of one medium voltage grid. This visualization on the left is just one cable going from one of the main stations like Pioneersweg that I showed you and ending up at the low voltage connection points with the households. So you can see all its branches and all the equipments there. What this calculation method does is just use some real measurements forecasts to estimate the remaining of the grid based on actual technical properties of each of these components and get to the most probable state of your grid. And then the equipments that we use in this process that are, of course, there are many other equipments, but what we look for or do further investigations in are the medium voltage cables, the low voltage busbar sections, the energy connections, which represent the the large clients in the low voltage and the small clients in the low voltage grid, which are just households. And then the power transformers in the points where you go from the medium voltage grid to the low voltage grid, and then basically the energy source from the Leander stations, and that is considered like the in-feed or the dump of energy within that route. If we go to the next slide, I just wanted to also cover up what we use as data inputs for the state estimation process to get a better vision of the grid. Is generally 5-minute measurement data for MV and LV power transformers and also MV LV connection points. However, the Leander grid has currently only 10% of these 45,000. They are smaller stations. We call them MSRs in a sense. So we only have 10% of these measured from the 45,000. So a lot of the forecasts are not available, or like the measurements are not available to be used in state estimation directly. So we also so we had to develop a new method generally to estimate what aggregated households are producing. And then a new initiative started within our company or within specific teams in our department to look into smart meter data. So they realized that due to privacy reasons, of course, households do record some of their measurements, but do not share them with the DSOs. And due to these privacy reasons, it's not allowed, or you can't directly have inputs on what a client produces or consumes. So another initiative started within the whole Netherlands, which allowed us to have access only in the case where we are able to aggregate these clients and then, of course, not know who are even aggregated in a way, so that we are allowed to generally estimate what a group of clients are doing. So with this method, we have created a method that aggregates five clients at a time, looks into their smart meter data, of course, jumbles up the names so that you don't know which client is producing what. And then you just look into one measurement, which generally reflects what a group of clients would do behind an MSR, and then grouping all of these, since you know how many clients are there, and estimating the people's behavior which don't have smart meters by assuming they are similar to the clients which do have smart meters. Then you have a much better vision of all of those tiny MSRs or the small substations that I mentioned that you were blind before, but now have much more inputs on. And then you can see an example in the next slide of how accurate this method seems or proved for these stations that we measured. And then LS meta generally just represents the blue line, which is just the real measurements in some substations. So we compared our basmati results, which are our estimates, with LS meta measurements, which are real measurements in those stations, in a couple of stations, just to verify the model is working properly. And as you can see, in most of the cases, they are quite aligned. So we did realize that aggregating households aggregating households smart meter data does not ruin actually the quality of your estimation, but only enhances it. If we could go to the next slide, Akhtar, thank you. And this all comes together at the end to a 5-minute real-time safety assessment happening continuously every 5 minutes on all of these points. On basically, the goal is currently we have only 500 MB routes in our system, but the goal is to cover the whole Leander grid soon. We're just expanding slowly. But then we have insights currently on 25% of the MB routes, which continuously do safety assessments, compare every equipment's estimated load or real load, depending on whether there is measurements or not, with the limits, the policy limits available there. And if there is an overload, alerts us so that we can take action. Of course, this method is still, like, the whole process is still in its start. It's not as developed as Mitchel was explaining for the HV stations, because there automatically clients are called, clients are expected to increase or decrease their load. Here, the process is still in its start, and we are working with other parties outside of Leander to accumulate these small clients and help us with grid. So we are signing currently these contracts, and soon enough, this process will be as developed as the HV one. Yes, thank you. I think the next slide is actually showing some live demonstrations of these two cases and what myself as an operator sees when he uses the GridMeister that Akhtar mentioned. Let me just share my screen. Sorry, do you see my screen now?
No, I don't. Are you using the share button on the bottom?
Yeah. Yes.
Maybe
Yes.
we need to take control first. Oh, yes.
Is it available
Yeah,
now? Yes.
It
Yes,
came.
there it
Yeah.
is.
Perfect. Let me just refresh the page as I have opened it a couple of hours ago. So here, this was a general case which popped up on our list. Let me just also share GridMeister. So when you open up the dashboard, you get to this whole fuzzy, not like a page with a lot of information on different voltage levels, different equipments or stations which have overload in the next coming 2 days. So for example, on Tuesday, you can see all of these equipment. You can filter out between the different voltage levels, what worries you or what not, or what you're there to see. Some of them are based on forecasts, some of them are based on real measurements, if they're measured overload, like the current one in Drachten. And these are all showing forecasts in the coming day. For example, here in Drachten tomorrow, we do expect the forecast, for example, to be over just a bit. And then we can also see the timelines or how much of an issue is available, and then contact the appropriate clients in the different markets that, for example, Mitchel explained before. Going back to our initial case in the Dronrijp, here, as you can see, around 2 megawatts of overload was expected on this day in a random example in May for a couple of hours. So what the automatic system did was start to find solutions for these clients. And then we were able to sign contracts. So we already had contracts in this area. So we sent out a request early morning at 6 a.m. specifying that in each PTU in these next 15 minutes in the next day, we needed all of these curtailments or powers to order, in a sense, to contact the clients. All of these messages are done, or communication with our clients are done automatically. So we connect to a platform called GoPax, and then this message is sent, and then the client responds, and then we fix, or we accept his request, and then we, of course, also modify our forecast to take into account the curtailments that the clients will do, so that it doesn't seem like we still have an overload right now, and the system still doesn't try to find a solution for that. And that is, of course, based on the difference between the forecast of the client and what we actually reduced. And then finally, I would also like to just touch upon this other case, which is visualizing an MV route with all of its components. So here, let me just take the toggle off of the bottleneck, and then you can see a specific case where a transformer had expected overloading on this day, and then you can do view chart to actually see when the overloads were expected, and then you can also see the different data sources going into the system. And this is done continuously, as I mentioned before, every 5 minutes for all the equipments in a quarter of the routes run by Alliander. So it's a continuous process, seeing if there are any overloads, and then starting a process to find solutions. However, as I mentioned, solutions here are not currently available, but within this year, we will also be able to do that and find solutions. Basically, yeah, you can also see any estimates of households, how much they're producing and whatnot. Sorry. Yeah. So yeah, that's it. Basically, I'd love to answer questions and hope that was a good introduction to what we do in system operations. Also, if you'd like, I can also quickly show the customer tab where we do verifications and whatnot, and save them all in our archive log of what verifications were available in different locations. And this Gridmeister, which is called currently Gridmeister, is further in development and will continue to do so in the coming years. Yes, thank you. I think Akhtar takes the sharing again.
Yes, perfect. So thank you, Manuel, for your part of looking a bit into the nearby future of capacity management, meaning tactical capacity management, and also for the demonstration of how does it actually look and feel when we're doing the work we're doing, and especially what you're doing on a day-to-day basis. So I would like to, before we jump into the Q&A session, quickly summarize with some key takeaways what we've shown you today. So, and basically Akhtar's first part, we're basically showing you, explaining you what is the framework, the regulation, the policy that we're working on, and how that has evolved since 2021. So that's basically 5 years in the making. And similar enough, that's also the time that we've been working on the solution and putting congestion management from a DSO perspective into place. Then we came over to Mitchel, and here I think really one of the key takeaways is, what does flexibility actually mean? It means being aware of the balance that you need to achieve between managing risk, the cost associated to mitigation, and then the actual time till delivery, and using this all purposefully. So as Mitchel pointed out, you want to basically find a good balance between activating mitigations and letting the mitigations rest and see, and accepting, for example, also the risk if it's minimal. So therefore, also those percentiles that we're working with are quite important to understand that. And finally, with Manuel, basically looking at how those solutions are also integrated as we are working towards the mid-future, so time frame from 1 to 3 years. Whereas Mitchel's part was basically in the here and now, basically 2 days ahead. Manuel's presentation also worked towards working and taking measures upfront to actual day-to-day business. So looking on what is the ideal solution for example, with beefing up that 1.6 kilometer line so that we can survive another season, and mixing it to the right balance between those technical solutions and the flexibility contracts where they're available. So with that, I think we can switch over to the Q&A session. We did see that there's already some questions popping up, and I already saw that they were also prioritized. So we have in total at the moment 13 questions, and I would just say that we'll try to answer them from the top to the bottom. So with that, I'll read. Yeah.
Mark,
David?
why don't I try to group them a little bit and then hand the question over to you. So there's a couple questions asking about, and I think Manuel sort of addressed this when he was going through his demonstration, but they're asking, are you just managing the thermal overloads, or is it also voltage constraints, or are there scenarios where voltage collapse or transient stability limits come into play?
Should I take that maybe?
Yeah, go ahead.
Yeah, so we take both voltage and thermal overloads into consideration. So if there is a voltage violation, we also, through the state estimation, we can find out the voltages. But we don't take into account the transient stability limits, because that would be, very demanding EMT simulations, and we don't operate in that time domains. Our focus is on the voltage constraints and on the overloads, so in the congestion domain, in steady state domain.
Great, thanks. There's another set of questions. They're sort of around the different types of flexibility markets, around do you help unlock demand side flexibility in both the up and the down direction? Is there pricing that supports that? For example, do they have time varying rates or something like that? Or is it more of a signal that's sent out in the day ahead or real time?
Yeah, that's a very good question, I think. And the answer is it depends a lot. So what we've seen in the past is that for large scale customers, large solar parks, large wind parks, generating customers, it's pretty easy to get flexibility. For factories, residential areas, basically the customers that consume, it's a bit harder to actually unlock flexibility. As well as for the smaller scale customers. So we're working on propositions in the Netherlands to actually enable, for example, small scale batteries or home batteries to actually be used in our flexibility request, or home chargers, EV chargers of your car, to also be aggregated and used. It's a very developing market in the Netherlands, and we're trying to prepare our system so that if the market is ready, we are also ready.
Maybe let me add to that also, just to really put it in some simple words. So what we're actually having in the Netherlands, right? So like Mitchel said, with the large generation parks, wind parks, solar parks, that we also sometimes just have direct bilateral contracts that we can activate on based on pre-negotiated terms. They are also still activated, so the communication for those activations is also happening through the local market, where the platform is called GoPax. But GoPax is then also, and that's the second market, also acting as a local regional flexibility market, so that we're close to a substation. Basically, if there are enough customers which are basically able to provide flexibility, then we can also issue basically an offer to which those customers then bid with their capacity. So that's all another part that we're having. So it's basically bilateral contracts and then real local flexibility markets. And what we also already have available, I saw that also a question coming up, whether to smaller scale, is something that we call in netbewusst laden, which is basically smart charging, where it's about municipal managed charging stations. And there we are communicating upfront, so ahead of time, access capacity on a 15-minute basis, 2 days ahead, rolling. And there, that information is used by the charge point operators to basically, allow the charging stations to operate at higher operational limits than what they might be working on if there's no excess capacity available. So those are some of the different tools and markets that we're using.
Sure. And so I think one of these questions is asking about like if there's too much solar on a feeder at one time, are you doing something to encourage maybe those electric vehicle charging banks to charge more during that time?
Yeah, so basically we have two options. If we have a contract, or if the solar park who is feeding in so much energy is running on a flexible contract, then we have the option potentially to ask him for reducing his in-feed. If that's not the case and we have customers who are able to consume more, then we would basically making our bet with them. Or, if possible, also combine both, for example, in the sense of a battery.
That's
Yeah,
correct.
maybe to add on to that, we also, have these big generators on a redundant line. So, normally we operate our grid in redundancy, but for these big generators, we normally operate them on in non-redundant line, and we ask, during the time when there will be peak, we will curtail you, and then so we try to curtail them if there is too much power at the same time.
Mhm.
But that's considered as the last solution. But we try to solve it by market-based solutions first.
Great. Someone asked, did you develop Gridmeister from scratch internally, or did you leverage some existing pieces from external providers?
Yeah, so we started developing this whole solution like 5 years ago, basically all from scratch, because back in the time there was nothing available on the market that we could leverage. And so therefore, yes, we have basically developing this all internally from scratch. But that also means, are we continuing that way? We started, for example, partnering with a software provider since last year, basically, or 2 years ago. And there we also have ideas to basically make use of the software platforms that are available.
Yeah,
Right.
maybe I can also add a small thing on this is that it's very nice that we develop it ourselves as well, because any learnings that we took from the system while running it or while communicating to clients, we were able to all include in our model and develop them better, in a sense, just by implementing or like listening to our clients, basically, or seeing operating it actually, and then seeing what is still needed, and developing it further.
Okay, thank you. Someone asked, what are the sanctions on a customer that doesn't follow instructions? You mentioned that, you showed a graphic of a customer not following instructions. What exactly are the things that you do to get them to follow instructions in the future?
Yeah, so it has several levels, so to say. So if this is the first time the customer did not explicitly listen, and the overload or the limit is small, we would generally ask the customer like, "Hey, is the setting correct? What happened?" We did have a case, for example, where we saw that the customer was actually deliberately taking the space it wanted to. And the worst thing could happen is that Alliander actually forcefully puts you off the grid. So, lifts your connection. This is something that we, of course, do not strive to, but it is the final solution. So it goes anywhere between calling the customer, sending them a monetary sanctions from X euros per megawatt hours to, kicking them off the grid, so to say.
Great, thanks, Mitchell. All right, here's a real quick one. What does GaaS mean?
Grid as a service.
Great, thanks. Someone asked, is anything happening around aggregator scaling for smaller scale flexibility in the Netherlands? So you can make better use of smaller scale flexibility for station constraints, substation constraints.
So what we're seeing is that there are basically flexibility service providers picking up, or aggregators. And the idea is you see this more largely where there's also heat pumps being installed, or charge point charging stations with the households or local batteries. So where then there's also actually the means to do some steering. It's not yet a largely developed market, but it is picking up, and that's also the strategy that we're following. So we're not going to address and connect all the small customers directly, but we're really waiting for aggregators to aggregate the small customers and then manage for us the connections and the flexibility. But
Maybe just
Mitchell,
to
Akhtar, if you have something additional, then you can join in.
Yeah, just to add on from the EU level, so there is new network code for demand response which is coming, and that would allow the aggregation. So I would say the pace, or the speed of aggregation would start once this network code comes into place. That would allow the rules and the market rules, how we should interact with the customers or with aggregators. So we are just waiting for the finalization of this new European network code on demand response. And then we will also develop solutions in the low voltage domain and in the aggregation domain.
That's an interesting development. Someone asked, it seems you order more response than needed, probably because you don't expect all the customers to behave correctly. I think maybe that was when Manuel was showing the example of what the tool looks like. How much margin do you build into your requests? So, like, how much do you expect?
Mitchell, maybe you can.
Maybe Mitchell, or
Manuel.
Yeah, okay.
Manuel, you want to take this one?
Sure. So it does depend per region. Different stations have different uncertainties that we see, because it all comes down to what is behind that station, what is below that station, what types of sources are generating the overload, or what issues are there. And so when we realize, we have also mechanisms that judge our forecast versus what is actually happening, and then based on this, we can play around with our percentiles for the different forecasts. If we see we are consistently requesting more, we will go to a more conservative percentile in the forecast levels that, for example, Mitchell showed before. And then I can't say a certain number for each of the stations, but it is somewhere with, I can't say a number, I think, but we play around with it at least, just to get closer to estimating what is happening. Yeah.
And I imagine it's something that you learn over time, so that you kind of fine tune how much extra you need to ask for different.
Yeah, and also the models learn themselves too. So there's two perspectives: the forecast of the station itself, and then the forecast of the client that you're calling itself. So any misalignment between any of these forecasts can go wrong, can lead to wrong results. So we have in our forecasting models, these are integrated, these learnings are integrated every time. So okay, we might miss a couple of actions or call them more, but then you can be sure that long term that won't happen. Yeah.
Mm-hmm.
Maybe this is also a good opportunity to explain a bit like the general framework, to maybe just zoom out a bit again. So in general, like Mitchell dropped it a few times, the system largely runs those identification and mitigations completely autonomously. So in in 96% of all those congestion issues that we're facing, the system is solving it completely automatically without any operator being active. And the 4 remaining percent, that's basically the job of Manuel and his team to really look and understand, okay, why couldn't the system automatically solve the issue? And then find, do a root cause analysis, being in contact with the development teams that are basically working on the solution, being in contact with the customer potentially to understand what was the issue happening, and then feed all that information first with a workaround, and then basically with a identified solution back to the development teams, who then basically improve the overall system so that on the next occasion this also runs automatically. So that's really basically how we set up the system.
Great, thanks. Someone asked about the cost of getting better visibility of the medium and low voltage networks. I think you had mentioned something like 10% of the system you have visibility into. Is there a reason that you're not getting more visibility into the rest of the system, or is it just really expensive?
So maybe I'll give it a start and then you guys jump in. So in general, basically, we are wanting to have more visibility, and we have different programs on how we do that. So this can be from placing IoT sensors, because I said that largely the Dutch grid is below ground, right? So there's also the option to, for example, measure the temperature of the ground and then correlate that temperature to the cable based on the master data of the cable that you have. So that's, for example, one quite easy sensor that we're placing in the across our grid area. Then there's the MSR, so that's basically the secondary substation measurements. So there we are basically improving the visibility and placing sensors as we see necessary, right? So that's also something on how we're not going completely all in and managing the whole grid all at once, but we're really going more in a clustered approach where we identify the most burning issues, so to say, and then clear all the data that we have for that area, and then basically bring it into our system as a managed area. And the same goes then with the visibility. So once we have identified an area where there's a congestion either coming up or already happening, then we're eager to place also their additional sensors. And then what Manuel also mentioned, basically since last year, we're also making more and more use of the smart meter data, as we now have the option to basically on an aggregate of 5 households, make use of the measurement that we receive from it. And that, as Manuel showed with the comparison of the graphs, is also proving to give us quite good insight on how the grid is actually behaving. So it's a balance between cost, urgency, and getting alternative ways of information on the grid. But in general, our aim is to increase visibility.
Yeah, just maybe to add, and I think that's also the reason why we don't have that much aggregation and low voltage customers, participating. So actually, we want to increase visibility, and when we will have more visibility, we will have more, the customers coming from the other parts of the grid. Because right now, most of customer participating in the local service market are the big customers, companies which can invest in the metering infrastructure. But that's the goal, that in future we want to go in a direction where small customers have these metering devices installed, and we can get more insight into the low voltage network.
Great, thanks, Akhtar. There is another question on here. I think we've gotten through all the questions except this one. Does Alliander forecast workforce shortages for engineers to deliver these solutions? This might be someone who's interested in working with Alliander.
So I'm I don't completely understand on which part you're aiming at. So we have engineers, of course, working on the software solution that we demonstrated today, and we have all kinds of specialists working together with the software solutions and software developers to do that. For example, also to work on setting up new kinds of flexible contracts and so forth. And then if the question is more to the field services, so that's also something where we're looking at. So basically the colleagues that are working on putting the technical solutions in place, right? Like extending the grid with new cables, with new stations and so forth. That's also something where we are working with our own workforce, but also with contractors. But that's not necessarily where we have our main focus from system operations on, but where then there are the colleagues from asset management and planning, the right colleagues to ask.
Yeah. Maybe also to just add here, this new process that we developed, or the tactical capacity management, is part of a bigger initiative within the whole company to better utilize the grid in a sense. And then by making all of these processes available for all of the departments to see, seeing the departments how they're contributing, there's a new work which was born, that wasn't available before, and what is new type of work that needs to be covered by people. So with this new process, that's how we generally have more insights of what we need to develop short term to cover up this middle gap until the stations are updated, for example, continuously, for which workers have already been set up. So the need is now being developed, and the hires are there, hiring already a lot of clients and colleagues to cover up what this need will generate.
Great, thanks, Manuel. I guess I'm going to take the moderator's prerogative and ask one last question before we wrap it up here. Large loads are a big thing that is it's a really hot topic right now in the United States. They want to interconnect much faster than the grid can be upgraded. Now I realize this is not so much on the distribution system, but really on the higher voltage system. But I am wondering, what can we learn from your approach that could be applied to, getting more data centers interconnected more quickly?
Yeah, it's a good question. So I mean, when you're looking also on the high voltage, so we were today focusing on the DSO side, right? But what we haven't touched upon, and what might have explained on the first capacity map part, there's also that our TSO TenneT also has capacity restrictions and is also trying to basically upgrade his part of the grid. And what we're learning really, and that's also a development that has been ongoing really, I would say, strongly last year, is to increase the communication and information exchange between the TSO and DSO, and also make available the flexibility that, for example, the DSO has contracted to the TSO, and also, for example, to do it the other way around. So there's really a strong focus to support between the system levels on managing the contingencies and the congestion part. So if you're asking, like, what can you learn from us when it comes to also connecting large consumers like data centers and so on, I think that's something where also the communication between the different operational levels from a TSO to DSO is something that's quite important, which we not necessarily have touched upon today, but also something that we are happy to share our experience with on another time or afterwards. So yeah, so I think that's one of the advices that I could give. And Akhtar, I think you're eager to answer something as well.
Yeah, so I'm also thinking about something like energy hubs. So we have in an area where there are bigger companies and they have a shortage of the capacity. So what we say to them is, you can make a group. So you big companies make a group and have one limit from us. So you have whatever you do within the group, and as long as you follow the limits we give you, that's fine. So the companies then can make a GTO. It's called Group Transport Contract, or our energy hub, where they can share the flexibility among themselves and try to to solve and they probably can also invest in energy storage and other technologies to keep the grid limits within the limits given by us, Alliander. So we are also working on energy hubs and those kind of other flexibility mechanisms for the big customers.
Oh, that's great. So I realize we're at the time limit now, and we're going to need to wrap up. I really want to thank you all, Mark, Akhtar, Mitchel, Manuel. This was a fascinating presentation. Really is going to be very helpful for the rest of industry, I think, globally. As I mentioned earlier, an email is going to go out to all the participants once the video file has been posted. We really appreciate everyone's engagement. Look forward to seeing everyone again soon. Mark, Akhtar, Mitchel, Manuel, thank you once again for this really timely, informative webinar. Thanks to all the participants for their interest, and look forward to seeing everyone again in the near future. Thank you.
Yeah.
Thank you for having us.
Thank you. Yeah, thank you for having us, and feel free to reach out via LinkedIn if you have also some further follow-up questions that you want to engage with us.
Oh, and I forgot to mention, for those who are interested in more information, we have on the Slido. Please include your contact information so that Alliander can reach out to you if you would like more information on this. Also, just feel free to email us at eSig, and we can put you in contact with the Alliander team. Thank you very much.
Yeah. Thank you very much. Have a great day.